This video is on linear regression and correlation versus causation. If I go too fast, just pause the video. You can rewind it. You can change the playback speed. So number one, draw a line of best fit and estimate its equation by hand. The scatter plot below shows the test scores of 10 students and the number of hours they spent studying for the test. So if I draw a line of best fit that goes through the middle of those points, you see that the starting value of that line is 60. That's the y-intercept. So A is not the answer. To find the slope of that line, you need to pick 2 points. So I will pick 0, 60, and then I will pick the point 580. And the slope formula is y minus y over x minus x. So 60 minus 80, 0 minus 5 gives me 20 over 5, which is 4. So the slope of that line is estimated to be 4. And if you look at your answer choices, the closest one to 4 is 3.3, which is C. Number 2. Now we will use the calculator, or Desmos. The table below shows the cost of a sub-sandwich based on the number of extras ordered. Which function represents the cost of a sub-sandwich with n extras added on? So I'm going to show you how to do this. You go to Desmos, and you click the plus symbol right here. Click the plus, and then you click the table. And you're going to put in your x values, 1, 2, 3, and 4. And your y values are 5.5, 6, 6.5, and 7. And then you want a linear regression. So you're going to click another line right here, and you're going to type y1. You just type a regular 1, and Desmos will make it a subscript. So just type y1, tilde, that's up in the left-hand corner of your keyboard, mx1 plus b. And Desmos will give you the slope, which is 0.5, and it will give you the y-intercept, which is 5. So 0.5 is your slope, and 5 is your y-intercept, which gives you answer choice A. Number 3, this time you have coffee based on number of extras ordered, the cost of a coffee. And again, it's asking for the function. So once again, you're just going to put them in Desmos. So 1, 2, 3, 4. And then this one is 2, 2.75, 3.5, 4.25. And y1 tilde mx1 plus b. My slope is 0.75 and my y-intercept is 1.25. So that is also answer choice A. There are 4 different types of correlation. There is 2 ones that are positive. Notice the line is going up. Strong means that the dots are close to the line. Think about a strong magnet. The magnet attracts things to it. So strong, the dots are close. Weak, they're more scattered. If the line of best fit is going down, that makes it negative. Once again, strong means they're close to the line. Negative means they're more scattered. Number 4, the scatter plot below shows the number of division errors students made on the test and the amount of time they took to take the test. So if you draw a line of best fit, it is definitely going down. So it is negative. So you can mark out A and C. And is it strong negative or weak negative? That is definitely strong negative. The dots are close to it. Number 5, examine the scatter plots below. The axes all have the same scale. Which plot shows the weakest correlation? So the weakest correlation would be B. The dots are very scattered. B, do any of the plots illustrate a negative correlation? Well, once again, that would be B. These A, C, and D are all positive. Which plot shows the strongest correlation? That would be C. The dots are closest to the line. Number 6, the scatter plot below shows the annual salary of 13 graphic designers and the amount of time they worked at their current job. Which statement is true? So it's hard to see these dots, but here is your line of best fit, which is positive. So you can mark out A and B, definitely is positive. Is it strong or weak? I would categorize that as strong. The dots are not too far scattered, so I would say strong. But that one is subjective. All right, now let's talk about the R value. The R value is the correlation coefficient. It is the value that tells you whether your data is strong positive, strong negative, weak positive, weak negative. So here are some examples of R values. If the R value is -1, that is a perfect negative correlation. That means that all the dots are exactly on the line and they're going down. +1 is a perfect positive correlation. Once again, if you need more time, just pause the video. So in this scenario, you have a line going up and all the dots are exactly on the line. So very strong. It's so strong that it's perfect. 0 means there is no correlation. 0 means there's no correlation. So if I had a scatter plot and the dots were like this, there is no correlation there. -0.9 is pretty close to -1. That is very strong. So that is strong negative. 0.05 is close to 0. So that is weak. And it is a positive number, which makes it positive. 0.8, also close to 1. Anything over 0.5, I consider strong. And this one is positive. And 0.1, that's less than 0.5, it's close to 0. That would be weak. And it is a positive number. So number 7, what type of correlation is shown in the table? Whenever it's asking you about correlation, that is the R value. So let's put this one in Desmos. $40, $75, $85, $110, $90, $55, $96, $50, $125, $140, $135, $160, $175, $157, $172, and $160. And come down here and you look. Here's the R value. Here's the R value. It's 0.4933 right there. 0.4933. Which is weak positive. It's less than 0.5. Number 8, what is the correlation coefficient for the linear model that fits this table? So the correlation coefficient, that is your R value. So I'm going to put this one in Desmos as well. And I'm going to go ahead and exit this out to show you once again how to do it from scratch. So my X values are 3, 5, 2, 6, 1, and 10. And my Y values are 18, 30, 12, 36, 6, and 60. And so to get the R value, Y1 tilde MX1 plus B. And for this one, your R value is 1. R value is 1. Number 9, the table below shows the amount of time students study for a test and their respective test scores, which describes the relationship between the time a student spent studying and their test score. So it's asking for strong positive, weak negative, and so on. Once again, if you know the R value, you can answer that question. So we're going to put this one in Desmos. So my X values are 25, 0, 10, 30, 60, and 75. And my Y values are 77, 72, 80, 85, 96, and 98. And my R value is 0.9594. 0.9594, which is strong positive. Number 10, Marcus measured the height in inches Y of plants over the course of 3 weeks. The correlation coefficient between the number of days X and the height of the plants is 0.85. What could be concluded based on the correlation coefficient of the data? So it's asking about the correlation coefficient, and it already gives it to you right here. The correlation coefficient is 0.85, which we know is strong. So we can mark out C and D. So what's the difference between A and B? They both say strong, but then it says as the number of days increases, the height of the plant increases, or as the number of days increases, the height of the plant decreases. The answer would be A. This is a positive number, which means that it's going up. The height of the plants is increasing. Number 11, which table best represents a linear model? Remember, a perfect linear model is either 1 or -1. So you want which table is closest to 1 or -1. So if I put in answer choice A, 1, 2, 3, 4, and 5, 8, 10, and 11, the R value for that one is 0.9759. If I put in answer choice B, 5, 15, 45, and 100, the R value is 0.9525. I'm writing those down. If I put in answer choice C, 4, 6, 8, 11, 2, 3, 4, and 5, the R value is 0.9944. And if I put in answer choice D, 5, 6, 8, and 12, -3, -5, -9, -17, the R value is -1. So it was asking which one best represents a linear model. That would be D, because this one is perfect. It's perfect negative, but it doesn't matter if it's positive or negative. It still makes a straight line, which is linear. Number 12, which one is not a linear function? Well, once again, let's look at the R values. So if you put the first table into Desmos, you will get an R value -4, -2, 0, 2, and 4, -10, -8, -6, -4, -2. This one gives you an R value of 1. Remember, we're looking for one that is not a linear function. If you put in answer choice B, this one gives you an R value of 0, which means it is not a linear function. All right, last thing we're going to talk about, correlation versus causation. When researchers find a correlation, that's also called an association. What they're saying is that they found a relationship between two or more variables. For instance, researchers found an association between using marijuana as a teen and having more troublesome relationships in mid to late 20s. When an article says causation was found, that means the researchers found that changes in one variable directly caused changes in the other. An example would be research showing that jumping off a cliff directly causes physical damage. In order to do this, researchers would need to assign people to jump off a cliff versus, let's say, jumping off a 12-inch ledge and measure the amount of physical damage caused. When they found that jumping off the cliff causes more damage, they can say it's causality. Causality. There you go. Sorry about that. Good luck recruiting for that study. All right, so last question. Which stated relationship is correlation but not causation? High intensity exercises increases metabolism. That is causation. If you exercise, it increases your metabolism. Lower crop yields result in higher produce prices. So if you have less crops to sell, the prices go up. That is also causation. Increased pressure results in increased temperature. That is also causation. If your blood pressure goes up, your body temperature goes up. People who attended college have more successful careers. That is correlation. If you go to college, it will most of the time help your career, but not